Hello everyone and welcome to my channel. My name is Bright, and in this video series we'll be looking at GIS and remote sensing. GIS and remote sensing and their application in our daily life. We also look at some tools. We look at some software that enable one to perform GIS and remote sensing. So for this video, it's just about introduction to GIS. We are going to take GIS first. So if you are a beginner, this is for you. This course is for you. If you are a beginner, this course is for you. You have this course and you are going to learn to understand it from all angles. Don't forget to drop your comment in the comment box, as I'll be looking at it and addressing your issues one by one. Let's get started. What is GIS? What is GIS? A lot of people have come across GIS without knowing what it really means. But today, let's analyze it. So when we talk about GIS, GIS just stands for Geographic Information System. Geographic Information System. Geographic Information System. Where when we talk about geo simply means the earth. Geo simply means the earth. So we talk about geo simply means the earth. And as we all know, graphic is visual representation. So we are looking at how to represent the earth's information graphically. Yes, how to represent the earth's information graphically. That's why geographic information system. And the system there, we are looking at the softwares, the tools that enables this information to be represented. That enables this information to be represented. And the information, talking about data about places, like say water, let's say data about water, data about roads, data about disease outbreak. So we are gathering information about the earth. Then we represent it using the right systems. That's you look at those systems. As we have the softwares, we have the tools, we have the techniques. They are all systems. So what does GIS do? It also helps capture, store, analyze, and display spatial data. When you talk about spatial data, you're talking about fixed positions on the earth. Fixed positions on the earth. Though the earth is moving, the earth is rotating, but the positions are not moving. The earth is moving together. So your position is not changing. Where your house is built is not changing. Where the road is constructed is not changing. Though the earth is rotating, it's not rotating, leaving the road behind, it's moving with the road. So the spatial data, we're talking about the fixed locations, positions on the earth. So it helps one to capture, store, analyze, and display. In this place, we'll be dealing with coordinates. We'll be dealing with various positions on the earth. So spatial data. And then also it combines a map with data to answer location-based questions. This time with GIS, we are not just looking at the map on a sheet of paper as we used to do in the Ptolemaic era. In the Ptolemaic era, where we just have to, use just the paper maps, But this time we will combine these maps with data. So the maps are not just drawn, but we have added some data called the metadata to it. So it will answer the location-based questions. Where am I? Where am I? What is my bearing? You see, all these things are detected using GIS, and that is what Google Earth is. So you'll be using Google Earth, and then you'll be knowing your actual location on the map. Yes, it's not like you're holding paper and you are finding your way out and a lot of errors. But GIS bridge that gap. It bridge that gap. And then example is where to build a hospital, which areas flat often, yes. Where to build a hospital? Where should I build my hospital? Where should I build? Look at it. Where should I build my hospital? Because you know the location, you know that this place is vacant, you know that maybe this place there are a lot of people living there, they can access the hospital. Yes, this place it has potable water, which can be also used in various ways. So which areas flat? Maybe this place is a slummy area. This place is based on the geological data we have. Maybe the soil over there has um, low permeability, and so the water is not able to penetrate properly, and flood occurs. So it helps you to map these locations in raw time. Yes. So now let's move to the next one. Let's look at the component of GIS. Component of GIS. So what are the components of GIS? When I talk about GIS, the components, so we have the hardware, the software, the data, and people. So you can see the hardware over here. Now, what are we talking about? What are we talking about when we say hardware? The hardware, we are dealing with the computers, the GPS devices, the hardware components you use to pick the data. Is it your phone? Is it a specific device you use? All those are hardware components. And GIS starts from the hardware, because it is the hardware we use to pick the data. Without data, we can't analyze to get this information. So the data, the hardware components, they are a major key component of GIS. The computers, the GPS devices, your phone. Do you have a tablet? See, all those you use to pick the information, they are hardware components. Yes, hardware components. And then we go to the software. The software, we are looking at the I told you about the systems. Yes, the softwares. We have the software that enable you to perform the GIS um, analysis. Like QGIS, we have the ArcGIS and the ADAS and other softwares that enables you to, perform these uh, analysis, the softwares. Then we have the data. When we talk about the data, we use the hardware to pick those data. Yes, the data, we have maps, and maps can deal with old maps. Maybe you are doing comparison, you are looking at change. Change you can compare with old maps. Old maps therefore become what? They become your data. Yes, so the maps, we have statistics. Statistics, let's say on weather, maybe statistics where maybe you go to a website, you get statistics on particular thing, let's say disease outbreak, then you pick those information to analyze. It becomes your data. We have satellite images like the Sentinel-2, the Landsat images. Um, all those are satellite images that enables one to perform analysis. So like Landsat, you can use to discover the land cover change. You can use to, look at some changes. You can use to look at a lot of things. The Landsat images, the Sentinel-2, the Sentinel-1, they are all satellite images, and they are all components of the GIS world. And then look at the people. Yes, important people. You look at here, you are looking at the people. You are important. If all the hardware, the software, the data are present without anyone to process them, how can the GIS be possible? How can you obtain the geographic information? You can't. So the users, the user, the analyst, the planner, yes, and they are all components of the GIS, because they also make the GIS possible. Yes, they are the key players because they have the knowledge, the intellect, the understanding to know which right method to use at a particular time, and so they are also components of GIS. Methods or rules for managing spatial data. Methods, they are not key components, but I decided to add them because they are also important, because you can't use any method to um, perform analysis on spatial data. No, there are key rules for managing them. Now let's look at next one. That's the real world application of GIS. We have the urban planning. Where we zone, where we look at the infrastructure design. Yes, urban planning. Uh, you know which building is supposed to be here, where should road be, where should um, the bridge be. All those are infrastructure design. And then we have the disaster management, where we map risk. We look at places where you have to take people out, like evacuate them. Look at maybe this place is flood prone area. Everyone has to leave so that we can remodel the place. Look at the evacuation plans. Yes. So all these help to manage disasters. And agriculture is important because with GIS we look at precision farming, where we can know the precise methods, the places where we have the right soil, the places where we can farm profitably, the acres of the land, the hectares, uh, so that we can do proper management. Yes. And then health, like I said, we can track disease. When COVID-19 came, many people use the disease tracking device, which dealt with using GIS to know which particular place the virus is densely populated, and we can track its movement, its origination, and how we can get rid of them. And we look at the resource allocation. Yes, resource allocation. And so navigation to route optimization, you can know maybe I'm traveling from maybe Alabama to, let's say, Ohio. I can know my distance. And then plan properly, because I know the distance. I can calculate the time of arrival. If I depart this time, I will get to the place this time. I have to get there, let's say 8 a.m. So what time should I depart so that I can arrive on time, considering that there's traffic? So you can optimize your route to know the better way of going about things. So we are going to end here for today. But what next should we expect in the next video? The next video, we look at remote sensing. We look at remote sensing singularly, and then we will see how remote sensing and GIS complement each other. Remote sensing is also a very key thing that everyone has to know so far as GIS is concerned. Remote sensing. So we are going to look at how remote sensing and GIS complement each other in our next tutorials or in our next video. So see you next. Please, if you have not subscribed, kindly like and subscribe to this channel, and like this video so that it can be recommended to other people also. Thank you very much. See you next time. Bye bye.